Hello again. In this video, I'm going to talk about numerical problems of acids and bases. In previous video, I talked about acids and bases, properties, definition, and we apply the information to identify them in the chemistry labs. But in this video, I'm going to talk about the relationship between acids and bases in the problems and how to measure amount of each one in any reactions or any solutions. First, I'm going to remind you when we work on the theories in the chemistry of acids and bases, we ended by Bronsted-Lowry theory. This is one of the latest definition and theories for these two groups of compounds. Bronsted-Lowry theory said H2O can act like an acid and base. H2O is going to produce what H3O plus hydronium, or water can make OH minus hydroxide. When we are going to study water molecules, we will find water molecule is a neutral compound. It means amount of H3O plus and OH minus hydronium ion and hydroxide ion is equal in water, pure water. Scientists use a new notation to measure amount of these two ions in pure water. So they said that at 25 degrees Celsius, if we measure amount of hydronium ion concentration, is going to be same for hydroxide ion, like this number, 1.0 times 10 to negative 7 molar at 25 degrees Celsius. If I use a formula in the bracket, it means concentration of that formula. For example, in this scenario, bracket H3O plus bracket. So when I write hydronium ion in the bracket, it means I'm going to talk about concentration of this ion at 25 degrees Celsius. If I'm going to talk about OH minus in the bracket, I'm going to talk about concentration of this one at 25 degrees Celsius. Here, I'm going to ask you, please remember that concentration is going to be reported by different units, and in this chapter, we consider only molarity. Molarity, we denote it by uppercase M. So if we are going to formulate relationship we have for water molecule as a solvent and any solution, we are going to end to this one. The reason, because if you have any solution, it means you are going to add your solute to water as a solvent. For example, I'm going to add NaCl to water. So whenever I have water, NaCl in water, water always going to make H3O plus OH minus. And it means I can write this equation for all solutions available in aqueous form, water as a solvent. So this formula is going to apply for all aqueous solution. H3O plus concentration times OH minus concentration is going to be equal to one number, one constant. We call that Kw. Kw, we call it ion product constant. Ion, hydronium ion, hydroxide ion, so we call it ion. Product multiplication of these two H3O plus ion multiplied by OH minus ion concentration is going to make one constant. This constant, as you may predict, at 25 degrees Celsius, you just need to plug in here, and you may get that one, 1 times 10 to negative 14. So we call that ion product constant of water. You need to memorize this equation at 25 degrees Celsius. This ion times that ion is equal to 1 times 10 to negative 14 at 25 degrees Celsius. So whenever we have this equation, we are able to calculate concentration of either OH minus or H3O plus. If I give it you H3O plus concentration and I ask you to calculate that one hydroxide ion for me, you just need to rearrange this equation. If you rearrange this equation, you end to this one. Or if I give it you OH minus concentration and I may ask you to calculate hydronium ion concentration, you can rearrange this one. Let's see how it works. Let's see how it works. Question says, if hydronium concentration in a cup of coffee should be like this one, calculate OH minus concentration, hydroxide ion. First, I need to write the equation, rearrange equation, then plug in here. Concentration of hydronium is this number given, and this one is a constant. If I calculate that, I may end to this number, 1 times 10 to negative 9 molar. So as you see here, we are able to calculate concentration of hydronium, concentration of hydroxide to get the answers. In this calculation, we are going to end by one specific summary, comparing the amount of ions, hydronium 10 to negative 5, hydroxide 10 to negative 9. So it looks 10 to negative 5 is greater 10 to negative 9. So you know that when we say hydronium ion concentration is bigger than OH minus concentration, it means we are going to have acidic solution. Hydronium is going to represent acidic solution, hydroxide basic solution. We reviewed that one in the earlier chapter, in the other video. So more amount of acids, less amount of base. So it means our coffee is going to be acidic. And in the real world, coffee is going to be acidic solution. Right now, I'm going to talk about pH. pH is going to use to represent acidic or basic solution in the chemistry. So for pH, we have 14 numbers. pH scale is going to start with 0 and is going to end to 14. 0 through 14. Acid and base, we have two major group of compounds. So if you divide 14 by 2, 7 is the border of acid and base. The number pH smaller than 7, we call it acid. pH greater than 7, we call it base. pH exactly 7, we call that neutral. They are conventions that we consider about that. Lower pH, it means we have a smaller number. Smaller number, it means we are going to make more acidic solution. So I'm going to work with this equation. What is the pH for this solution? Please remember the formula for pH. pH is negative log H3O plus concentration. Negative log as hydronium concentration. So let me plug in the equation. Negative log, and I am going to say 1 point times 10 to negative 5th molar. Whenever the coefficient is 1 for your number, for your concentration, if you calculate that one, you can easily get this one. You can get easily 5.00. One possible question, why we didn't report as 5? We say 5.00. We have one rule for sig figs. Please write the rule. I'm going to repeat that one a couple times to make sure you understand this. Sig of concentration, sig of concentration is going to be same as decimal places of pH. Sig of concentration is going to be same as decimal places of pH. Let's see what does that mean. Look at this one. Sig of concentration. This is a concentration of H2O+. How many sig figs for this number? 2 sig figs. 2 sig figs. I said sig fig of concentration means 2 in this example. It would be same as decimal places of pH. Whenever you are going to report pH, you need to report same number, 2 decimal places. So when we say sig figs for concentration is 2, it means 2 decimal places for pH. pH is 5, so based on our convention, we may say this is an acidic solution. So this is the example we reviewed for coffee. So if you had difficulty to understand this solution is acidic or basic based on the number we have, you just need to calculate the pH. And you see the pH is 5, less than 7, so we call that an acidic solution. For our body, we may able to measure the pH of our fluids. So mostly we have the lower pH in our stomach whenever the body is going to digest the meal or any foods we served. So the lowest pH belongs to this one. For other parts, as you see here, we have higher pH. And it's good to know the blood pH is going to be close to the neutral. And we have a bit acidic pH. The reason because we have oxygen there, iron there, and they are going to carry by the blood, and that is why we are going to have acidic pH. I don't want to talk about the details, but if we have acidic and basic solution, or in general acid and base, we have one reaction between them. This reaction, we call that neutralization reaction. Reaction of adding acid to base is going to make salt and water. So products of acid and base reaction are salt and water. This reaction, in general, we call that neutralization reaction. You will see we are going to talk about one specific reaction of double displacement reaction. One compound acid reacts with another compound base. Reaction of two compounds is double displacement reaction. You are going to change the first part of each one. So you will see salt and water as product. So please memorize that. Acid-base reaction is producing salt and water. The process we do to measure concentration of either acid or base, we call that titration. So this is a term we use in chemistry lab to measure amount of solid or base in a reaction of acid and base. To do that, we may need to remember neutralization means amount of solid must be equal to amount of base. Amount means moles. SI unit for quantity, amount of any substances in chemistry is moles. So when I say quantity of base is going to be same as quantity of acid, it means we are talking about moles. Moles of acid must be same as moles of base. Same. Moles, acid, same moles, base. One thing you should know, when you work in the lab, you need to identify this condition by doing one experiment. We call that titration. You need to use indicator to see when you have this situation, when you have this condition. If you have this condition, we call that endpoint. It means we could make equivalent amount of each one in the solution. We could make same amount of acid and base in the solution. We call that endpoint. Sometimes we call that equivalent point. We are going to solve our problems. Titration. How to solve this problem? This is not new problem. We already worked with this problem in solution chapters. Question says, what is the molarity of HCl solution if 22.5 ml of 0.100 molar NaH solution are needed to titrate a 25 ml sample of acid? Please remember, when we say titrate, it means we are going to talk about a process of neutralization. It means we are going to make same amount of acid, same amount of base. First, I am going to write the information given by the problem. So it looks we have information of base and we need to find information of acid. Whenever you have any problem to solve, first start with the compound you have both information. All information for NaOH is given. So I'm going to start with this one. Then I'm going to calculate for HCl. So first, let me start with this one. Whenever you are going to start, always start with volume. It's easier to work with that. So we are going to make moles of this one, So I'm going to say that we have 22.5 ml NaOH. I'm going to convert that one to liter because for molarity, we need to use liter based on the definition we have. Then we talk about NaOH. So I'm going to convert that one to moles by multiplying by molarity. So I converted to liter first, then I'm going to convert to moles. If you do that, you are going to calculate moles of NaOH. So this number is like this. So first, I converted volume to liter because I need to use the molarity definition. Molarity definition is mole per liter. So that is why I used liter. So then I multiply by molarity of NaOH. So this number is moles of NaOH. It must be same as moles of acid because we call it neutralization. Neutral means moles acid same as moles base. So moles acid should be like this one. So I'm going to write like this. These moles, look at the reaction. Moles NaOH is 1, moles HCl is 1. So when you write the conversion factor for moles NaOH to moles acid, you may get that one. So I found out moles acid and moles base should be like this. It confirms by the reaction. And the last step, I'm going to convert the moles of acid to molarity. Moles of acid, I calculated. Volume of acid is given by problem. Please remember that. Is given by problem. But it's given in ml. I'm going to convert to liter. So whenever you convert to liter, you may get like this number. So when you solve your problem, you may get this answer. Moles, I calculated. Volume given, I just converted to liter, ml to liter, and I just apply the molarity definition. This is the equation we use to solve our problems. One thing, always remember sig figs. 3 sig figs for this problem. So I applied 3 sig figs for this. We are going to work on more examples in our class. Thank you for watching this video.